Viewers and everyone who has tuned in and those who are yet to tune in, I want to greet you all. I hope you have had a fantastic week. So have I. So I want to thank God that we are here today to do our Chemistry Wednesday. For our viewers, this is our normal Chemistry Wednesday, as we have been doing for the past 14 or so weeks. So I want to welcome you to our lesson today. We have been having a discussion recently on organic chemistry, and we are continuing. We've built up on the topic and we are continuing. We are almost through with organic chemistry 1, and then we look at organic chemistry 2. So feel free, let us interact. Again, I want to thank all the students that have been viewing. I know one of you proposed that when we are through, we do those practice questions at the end of the unit. I want to promise you that that has been taken into consideration. So anytime we are through, we go through those questions, and then all shall be well. There are some of you that sent me questions. I have already tackled them. I have sent them back to you through. So you check your inboxes and the comment box where we have the video. So for those who still have questions, I want to encourage you, keep on asking, keep on posting through whatever channel, through YouTube, through the Facebook page, and even the inbox. So you can send them freely, and those questions, for those who have already asked, they will tell you the questions are answered in time. So welcome for today's tutorial. Today we are going to look at chemical properties of alkenes. We have done alkenes, quite a number of lessons about alkenes. We have looked at how alkenes are named, that is nomenclature. So we started by looking at nomenclature of alkenes. We looked at isomerism of alkenes. We said alkenes have two isomerism, or two types of isomerism, that is positional isomerism, and we said we have positional isomerism. It exhibits two types, and branching isomerism. So where positional isomerism is referring to the position of the double bond or the position of the functional group, and then branching isomerism refers to the position of the branch. In all this, we said you name the isomer that is present there, and giving the number and giving the position and the type. If it is a branch, then the type of a branch, just as we did in our previous lesson. So that is it. We also looked at preparation of alkenes, how alkenes are prepared. We said alkenes are prepared by dehydration of alkanols, basically by use of a dehydrating agent, which is concentrated sulfuric acid. Also, we said aluminium oxide can be used both as a dehydrating agent and as a catalyst. So that is what we did in our last lesson. So today we look at the chemical properties of alkenes. Now, the first chemical property, we call it combustion. Combustion. So combustion is burning of substances in presence of oxygen. Combustion is burning in presence of oxygen. So alkenes, maybe we can say alkenes burn with a blue non-sooty, no, sorry for that. Alkenes burn with a, not blue, but burns with a yellow sooty flame. Now there is something I forgot to mention when we were looking at alkenes, and that is what is cropping up now. Now alkenes, what I forgot to mention is alkenes burn with a blue non-sooty flame. Okay, alkenes, because they are saturated hydrocarbons, they burn with a blue non-sooty flame. But alkenes and alkynes burn with a yellow sooty flame. This is because due to the high carbon hydrogen ratio. So alkenes and also alkynes, as we shall see, they burn with a yellow sooty flame. And of course, because they have a high carbon hydrogen ratio. What it means by high hydrogen carbon ratio, if you compare, this is just a comparison, if you compare alkene like ethene is C2H4 and ethane is C2H6. Okay, see, this is ethene, this is ethane. Now carbon, we have 2 to 4. That means this is 1 to 2. That's a half. In this case, other case here, the ratio is 2 to 6, which is 1 to 3. So if you check, a half of course is greater than a third. So this one burn with a blue non-sooty flame, this the alkenes, and alkene burn with a yellow sooty flame because the carbon hydrogen ratio is high. So that is what we can say about alkenes combustion. So if we have ethene, C2H4 burns in oxygen to form carbon 4 oxide gas and water. So when alkenes are burned in air, actually all hydrocarbons, we have all organic compounds actually burn in water, burn in oxygen to form carbon 4 oxide and water. Balancing that, these two will be 4, 2 there, then 3 here. So we have 2, 2, 3, 6, 4, correct. So that is how alkenes burn in air to form carbon 4 oxide and water. Number 2, that was, so one was combustion. Let me check my numbering. That was number 1. So number 2. Number 2 is addition reactions. Addition reactions. Okay, addition reactions, we can say these are types of reactions. Addition reaction is a type of reaction that involve reduction of unsaturation to saturation. Okay, I don't know if that is good English, type of reactions involving reduction of unsaturation to saturation. For we have said already that alkenes and alkynes are unsaturated hydrocarbons, and then alkenes are saturated. So these are unsaturated hydrocarbons. This one is saturated hydrocarbons. So when we say reduction of unsaturation, it means these are reactions where double bond or triple bond is reduced to single bond. If it is ethene like that, then it is reduced to single bonds like that, as we shall see. So the first addition reaction, Roman 1, is called hydrogenation. Okay, hydrogenation. So hydrogenation from the 1 is simply addition of hydrogen. So this one is addition of hydrogen. So this is ethene. When hydrogen is added, hydrogen gas is added there, then you have ethane. Okay, this is ethane. So it's a reaction where ethene is reduced to ethane. Here we have a double bond. In this other side, the double bond breaks so that you have single bond and hydrogen is added. So initially we had 1, 2, 3, 4 hydrogens, but here we have 6. 1, 2, 3, 4, 5, 6. As we said when we were doing covalent bonding, when you write H2, this is a molecule containing 2 hydrogen atoms. So it is hydrogen molecule like that. So when this reaction takes place, then this double bond is broken to have a hydrogen radical and another radical there. So this hydrogen adds to this carbon and this other one adds to the second carbon. So you have from ethene, you have ethane. Now there is a condition and that is necessary for this reaction to occur. We must have a nickel catalyst or platinum. Nickel or platinum catalyst, and temperatures of between 150 degrees Celsius to 250 degrees Celsius. Those are very important conditions to note. One, there must be a catalyst, either nickel or platinum, and there must be temperatures of between 150 to 250 degrees Celsius. So these are the conditions in which hydrogenation reaction takes place. Basically, when you are asked about this, then the reagent is hydrogen. The condition is nickel catalyst or platinum and the temperatures of 150 to 250. That one reduces double bond to single bond. Similar to all the other alkenes. If you have propene, then it adds the same way, reducing the double bond to single bond. Number 2 is hydrohalogenation. Hydrohalogenation. Now that was the first addition reaction was hydrogenation. The second addition reaction is hydrohalogenation. Hydrohalogenation, you break it down into 2. Hydro to mean hydrogen, halogen, simply halogen, and then that one represents a process. The TION represents the process. So it's called hydrogenation. It is addition of a hydrogen chloride. For example, we have hydrogen chloride, hydrogen fluoride, hydrogen iodide, and we have hydrogen bromide. So addition of these to an alkene. For example, you have ethene. So we are using ethene to represent all the other alkenes. And then you add hydrogen chloride. This forms and a chlorine there. So you have, this is ethene, okay, with the double bond. Add hydrogen chloride, and then you have this one, because now let us name this compound. We have the longest carbon chain contains 2 carbons, the longest chain, which that means it is ethane. So ethane with 1 chlorine, so this one we call chloroethane. Chloroethane. In any case, we have reduced the double bond to single bond. So that is number 2. This one does not have conditions. It just occurs like that. Number 3 is halogenation. Halogenation. Now, halogenation is also addition of an halogen. So you have, if you had alkene like this, and then you add maybe bromine gas, then you have that is what you will have. So this one is ethene. Okay, this one is, you have 2 bromines. So you have 2 carbon atoms, that is ethane, and then you have 2 bromine at carbon number 1 and at carbon number 2. So this one is called 1,2-dibromoethane. 1,2-dibromoethane, because we have bromine. When the double bond breaks, when you further education, you find that when this double bond breaks, one comes there and the other electron goes here. So you will have a radical. Now, when you have a radical, this one also breaks down, this bromine. So this breaks like that, okay? This is what you do in synthesis. So this one breaks, that breaks, then you have a radical. So this bromine now adds here. So you have a bromine there. And then this other one adds this side. So you have one there. So that's why we are saying it occurs. You remember when we were introducing alkenes, we said because they have a functional group, that is where the chemical reactions occur. Chemical reactions occur across the double bond. So that is halogenation. Also, this one does not require any condition, does not require any catalyst or temperatures. Now, this reaction should not be confused with the one that we did for alkenes. In alkenes, when we were looking at alkenes, we looked at almost similar, but we said this one is the reaction in alkenes. Here it is halogenation. For alkenes, we call it substitution. And there was a condition we mentioned, that we must have sunlight or UV. So this one is different from that of, this is halogenation. For alkenes, it was substitution. So that is it. So that's number 3. Number 4. Number 4 is called self-addition. This is another name for polymerization. Addition reaction or polymerization. Now, addition reaction is, self-addition reaction is where an alkene adds to itself. Okay? An alkene adds to itself. For example, you have this is ethene, reacts with another ethene. As we said, this bond will break, this breaks like that. Now when the double bond is broken, then it forms a substance of this, a compound of this kind. Okay, so this 1, 2, 3, 4, the 4 carbons join. Okay, so you just break this bond and then you join all of them so that you have 1, 2, 3, 4. Now this one, you enclose it, it is enclosed with a square bracket like that. Okay, it's enclosed with a square bracket where the square bracket crosses with this line, the bond here. This is a covalent bond extending to form the tetravalency, to complete the tetravalency of carbon. So we have this and that, and you had 1, 2, so these are two molecules of ethene. So this one is called ethene, this one is called ethene, this one is called polyethene. Okay, this is called polyethene. Now this is 1, 2, so you have 1, so you, when you look at this, you can break it into 2. You have this side and that side, so you have 2. Now generally this can be represented by alkene undergoes polymerization under high pressure to form this molecule okay. This one is ethene. Okay, this ethene. The ethene is referred to as a monomer. This is a monomer. This one is now what we are calling polyethene. Some people call it polythene. If you like, you can omit the E and then you say polythene. The one that was banned the other day by NEMA, that it pollutes the environment. So this polyethene is now called the polymer. Okay, so this is a monomer, another monomer, and then it forms a polymer. Now when I said this N represents the number of monomers, so N is equal to number of monomers. Okay, they can be 2, they can be very many in a chain depending with the chain. So that is called polymerization. The condition is high pressure, like 750 to atmosphere, 750 degrees centigrade. So high pressure. Now, so that's polymerization. So you can have polyethene. You can even have polypropene. If you had propene, like that, it undergoes polymerization, then you will have 1, 2, 3, 1, 2, 3. You extend this. Of course, we have the hydrogens. Then you enclose it with a square bracket where it shows, okay, this one must cross, okay, and here also like that, and then M. So this one is propene, this one is polypropene, etc. So that one is called self-addition. Self-addition reaction. Now, when we look at organic chemistry 2, we will look at another type of polymerization. So basically there are two types of polymerization. We have addition polymerization and condensation polymerization. So alkenes, maybe we can say alkenes are the only group of organic compounds that undergo addition polymerization. Okay, they are the only group of organic compounds that undergo addition polymerization. So that one is addition polymerization. Now N, the number of monomers, can be calculated by the formula N is equal to molecular mass of polymer, okay, divided by molecular mass of the monomer. The number of monomers can be calculated by the molecular mass of the polymer divided by molecular mass of the monomer. We shall look at an example of this. Let me see if I can find one here. Okay, we shall come and look at examples of this. I'm not finding one right away. So just to know that, and what we showed by this, so we are saying N can be calculated by the molecular mass of the polymer, which you will always be given, divided by molecular mass of the monomer. As for the monomer, you can always calculate the molecular mass by adding the molecular masses of individual atoms that constitute to that compound. So we shall still come back to this to look at problem solving involving this kind of polymerization. So what is very important to note is how to write the polymer and the fact that polymer can be divided so that you have monomers. So that is addition polymerization or self-addition. Number 5, another addition reaction is called oxidation or oxidation reaction. So oxidation reaction is the addition of an oxidizing agent. Now in chemistry we have two major oxidizing agents. We have potassium manganate 7, which you students normally call it KIMNO4, and then we have this one, I don't know how you will call it, kikri. This is KIMNO4. Now this one is kikri something. So this is potassium manganate 7, this is potassium dichromate 6. These are the major oxidizing agents that we have. This potassium manganate 7. This one is potassium dichromate. Dichromate 6. So that is these are the two major oxidizing agents. Potassium manganate 7 is purple in color. In the dawanyoka. Okay, in the way they dawanyoka. So this is purple in color. This one is orange. Potassium dichromate 6 is orange in color. So when we say oxidation, it now means addition of an oxidizing agent. Addition of either this or this. Now, if we had alkene like ethene, this ethene, when potassium manganate 7 is added, or potassium dichromate 6, we normally represent it as okay, this represents either one of them. This oxygen in a square bracket is an oxidizing agent. H plus shows acidified. So you normally hear of acidified potassium manganate 7. Acidified potassium dichromate 6. So when you write like this, it means addition of an acidified oxidizing agent. So this gives you so it forms this. This one is called, when we do organic chemistry 2, OH, the functional group OH is referred to as ol. It's called ol. Okay? You remember double bond is in, triple bond is ein. OH now is called ol. So this one is, because this ethene, okay? Now let us name this one, this compound here. So when we are naming, the parent is, we have ethene. Okay, the parent is ethene. Now because it has functional groups, you have two functional groups. This carbon number 1, carbon number 2. So you have two functional groups at two different positions. So this one is called, it is supposed to be ethanol. Okay, it's supposed to be ethanol, but we now call it ethan 1,2-diol. Look at the name. Ethan, to show that it is 2 carbon atoms. And then 1, 2 to show at position number 1, carbon number 1 and carbon number 2, we have 2 ols. Okay? So this is 1 ol, second ol. So we have 2 ols. That's why we are calling it a diol. So it is supposed to be ethanol. But now because there are 2, then we call it ethan 1,2-diol. So any alkene undergoes oxidation to form a diol. Okay? If it was a propene, then it forms the same thing. The only difference is we will have 3 carbon atoms, but for this one is 2. But this OH adds across a double bond. Okay? It adds across a double bond. Now maybe one thing we should mention about this is that when potassium manganate, okay, in this reaction, the purple color of potassium manganate 7 decolorizes or is decolorized. Okay, the purple color decolorizes while the orange color of potassium dichromate 6 changes to green. Okay, so the orange color changes to green for potassium dichromate 6. For potassium manganate 7, the purple color decolorizes or potassium manganate 7 is decolorized. Okay, let me just remind you one thing here. When you are doing organic practicals on organic chemistry, that is question 3, you normally have observation, and inference. For those who already have done this, so you are told in the procedure to the substance in a test tube, you put 2 cubic centimeters and then you add 2 cubic centimeters of potassium manganate 7. Then your observation is purple color decolorizes. Okay, so the inference is you have a double bond or triple bond present. Okay, now this is what is shown here. So that when you have potassium manganate 7 or potassium dichromate 6, purple color changes to colorless, then you have double bond or triple bond present in that compound. Otherwise, if it is potassium dichromate 6, then this is 1. 2, if it is using potassium dichromate 6, then you say orange color changes to green. Okay, the same inference. So that is what you do for paper 3 for those who have already done it. So that one is oxidation reaction. Number 6, our last one for today for now, is addition of sulfuric 6 acid. Addition of sulfuric 6 acid. We have 2 steps here. So you have our ethane there. Then sulfuric 6 acid is added. Now this sulfuric 6 acid, you know we have 2 hydrogens and sulfate ions. So this is broken down to hydrogen and hydrogen sulfate ions. Okay, it is broken down. This one is broken down to hydrogen ions, which is a positive, and hydrogen sulfate ion, which is negative. Then this one now adds to one side. This adds to one side. This adds to the other side. So you will have a compound of this kind. This is okay, I can write SO4H. This is H, this H. The trick is just this adds to one part and this hydrogen adds to the other side, so that the double bond is broken. So whichever way you write it, somebody else will write OSO3H. Is still the same thing. It is still HSO4. So this one is called ethyl. I did not want to come this side because it is one name. So let me start here. It is called ethyl hydrogen sulfate. It is called ethyl hydrogen sulfate. Ethyl to represent C2H5. You remember C2H5 is an ethyl. And then hydrogen sulfate to show that thing present there. So this one is called ethyl hydrogen sulfate. Now when ethyl hydrogen sulfate is added, when water is added here, so if we have to further that reaction, when water is added and then it is warmed, Okay, add water and warm. Then this one becomes, so when ethyl hydrogen sulfate is warmed, then you have ethanol. This is ethyl hydrogen sulfate. Okay, so when you have that ethyl hydrogen sulfate, add water and a little warming is done, then it forms ethanol. This process here is referred to as hydrolysis. The process is referred to as hydrolysis and is the exact opposite of dehydration. Now dehydration, we said, ethanol is dehydrated by Kong sulfuric 6 acid. So when the process is reversed, then that one is called hydrolysis. So this process is called hydrolysis, and it leads to formation of an ethanol or an alkanol. So those are the addition reaction for alkenes, and also the same will happen for alkynes when we reach there. Okay, so maybe for your part you can find out the uses of alkenes. Find out the uses of alkenes. We had mentioned some of them, some of the uses when we began to look at this particular topic, the organic chemistry part. So that is our lesson, and those are the chemical properties for alkenes, and they are 6 in number, actually 7, because the first one was combustion. Then we have 6 addition reactions. So that is those are the chemical properties of alkenes, and you find out the uses of alkenes, and I think we shall be okay. So if there are any clarifications that you want to be made, then you can inbox me or put them in the comment box, and then I shall get back to you. So when we are done with this next week, when we will be done with this, then we shall look at a few questions concerning this organic chemistry, as one of you requested. Otherwise, I hope you have enjoyed today's lesson. For those who have tuned in, I know for those who will tune in later on also, I want to welcome you and hope that you will enjoy. So that is it for our presentation today. Thank you for coming around. Keep it here every Wednesday. We have a Chemistry Wednesday, always at 1 to 2 p.m. So I want to say thank you up to that point. May God bless you until we meet again. Bye bye.